Hello, I'm Alien Scintillare, and welcome to this tutorial of Intel AMT Commander and Intel AMT Outpost. I'm going to go and cover basically network filters, network policies, and Watchdog agents in this tutorial. And this is probably one of the trickiest tutorials to do. What I'm going to do is actually record the screen of the computer that actually has AMT on it. So this is the computer here that you're seeing the desktop of that does support AMT 2.1, and the way I'm going to use Commander to connect to it is actually bounce through my router and back into my own machine. So I'm going to go ahead and do that. So this is a little bit of an unconventional way to do a tutorial, but it will allow me to basically run Commander and run Outpost at the same time on the same machine and kind of see the interactions between the two when it comes to network policies. In addition to these two applications, I have in the corner here the application called Net Status, and it's a little application that basically pings my gateway constantly. So there's a little gateway here that I have on my network, and it's constantly pinging that gateway and receiving response from that gateway. Now the reason why I'm running this application is that it will tell me whenever it loses connectivity to my gateway. So it will actually show that I'm having an impact on the network policies through AMT. So let's go ahead and get started. So I have Outpost here, and normally Outpost would be an application that runs as a Windows service. You wouldn't have a UI for it. But right now, as a development tool, it's provided with a UI just as an app, and it's easier for me to debug also. We have a way to type in a login name and password to connect to the local interface of AMT. We have Watchdog that we're going to cover in a minute, and we have other things like the redirect log and serial agent, which we covered before. So let's go and put Outpost on the bar here, focus on Commander, and what I want to cover is the networking portion of Intel AMT. Now, basically the way this works is that you have filters, policies, and watchdogs. Filters don't do anything by themselves. They basically say, this is a type of traffic I'm interested in. And so you can create a filter. I'll just go ahead and say add filter. I'll call it, this one, ICMP drop. It's going to be an IPv4 packet filter. It's going to be for outbound packets, and I'm going to set the profile to drop the packets. I'm also going to specify the protocol as being ICMP and the outbound IP address to be one that's within my my domain. So basically here what I'm saying is that check this filter for IPv4 packets that are going outbound on the NIC, and if the outbound address matches anything on the 192.168.5, anything else, because of this net mask, everything that's ICMP that's outbound to that the outbound portion of the packet matches this filter, then trigger. And whenever I trigger here, what I'm going to do is drop packets. And I can also, by the way, say statistics drop packet. That means count the packet and drop it. So I'll actually do this one. It's a little preferable. So I can also select that when this filter gets triggered, a log entry gets created into the event log. So I won't do it this time, but you could do that if you wanted to. I'll click add, and this will add a new filter called ICMP drop. Now when I add a filter, nothing really happens. It just defines a filter of what that could be used, but filters are only used when they're part of a policy. So I'll go ahead and create a new policy, and I'll call it the ICMP drop policy. I'm going to select, as part of this dialog box, you can select all the filters you want to use, and I'm going to go and select the one I created. There's also, as part of AMT, 3 default filters that are always there. Basically, they're not shown up in this list here, but they're always there and you can always use them as part of any of your policies. The first one is called the anti-spoofing filter, and that's an IPv4 only filter. It basically triggers whenever the outbound packets that this machine is sending does not have an IP address on the packet that matches the IP address of the machine itself. So if somebody's trying to fake being another machine, then this this filter will trigger. And what you can do is say whenever this filter trigger, basically you can count the event, or you can also log it. Now there's also two more broad filters that are always there. One is a basic all transmit and all receive filters. So this is the all receive, this is the all transmit. And you can say, for example, all packets that are received do something like drop the packet or count the packet or trigger an event, or all packets are received. Now just for this policy I'm going to select only my filter that I've created here, and this is a precedence. You can use it if you have multiple policies to set a precedence. I'm going to say OK, and it just created a new policy called ICMP drop policy. Now right now the policy is not active on any of my network cards. Now I'm going to open up my net status again, which is currently pinging my router, and I'm going to go ahead and activate this policy on my wired NIC. Now wireless, you can activate also on wireless in future version of AMT, but right now only wired is supported. So I'm just going to go and trigger that. Now you notice that the alert just popped up and net status cannot ping the router anymore. And actually that's because the filter that I have here matches outbound packets and blocks basically all the outbound packets, ICMP packets from net status to go out. So if the router were to send a response back, it would actually work, but the send is not working right now, so it's not allowing net status to ping anymore. Now another thing I can do is go in policies and say start the policy monitor, and I can click auto refresh. And what's interesting about this is it basically, if you remember, I activated the statistic counter, and it's counting how many times that ICMP drop packet is being matched. So receive packet, send spoof packet, and send packet, these are the three statistics for the default filters, and filter number 9 happens to be my ICMP drop packet here, and you can see that it's matched, and so it matched at least once. The count is more than 0, so this will show the true, and right now it's counting up because it's blocking all the packets that are coming through here. I can close this. If I go and say activate and I just remove the checkbox, you notice that immediately it started working again and my ping works. I'll go ahead and do another policy, add policy just for the kicks of it, and I'll call it the all packet policy, and I want every packet to be counted on transmit and received. So I'll call it the all packet count policy. Now actually there's a limit on the number of letters in the name here, so all packet count will have to be the name I give it. So I'll go ahead and activate it on my wired NIC and take a look at the policy monitor. And now you can see, I'll hit auto refresh, you can see the packets being sent and received from this machine. Now these are the packets being sent and received by net status, but also any other packets from all the other apps on this machine that are being sent and received here will show up. So this is kind of interesting because you can see how much traffic is going in and out of this specific computer. Okay, so I'm going to close this, and I'm going to go and remove this policy. Now we're going to play another trick here, and we're going to take a look at watchdogs. Now that we understood filters and policies, and we got my policies set up, I want to take a look at watchdogs. Now watchdogs is the ability for you to monitor a running application on the computer, on the AMT computer. So the first thing you do is you click on Watchdog, and the Watchdog engine has one policy it can be set to. So I'm going to set it to the ICMP drop policy on the wired NIC. I don't have a wireless NIC that has AMT support, so I don't get this. But I'm going to set this as the main Watchdog engine policy, the ICMP drop. Now I'm going to go ahead and create a new Watchdog. I'll call it sample Watchdog. The identifier here, this is a GUID, a unique identifier. I can generate one, or I can leave it to all zeros. And the first timeout is basically the timeout in seconds at which the application on the AMT machine has to ping. And if it takes more than 10 seconds without receiving a heartbeat, well, it will basically trigger this Watchdog. And when the computer first starts up, it has 30 seconds before the application starts pinging, otherwise it will trigger that policy. So these are basically two reasonable timeouts here. I'll just go ahead and add this Watchdog. Okay, so here's the Watchdog. Now it has the identifier, has the timeout. If you look at the current state, it says not started yet. So there's no application registered to start heartbeating this policy. Now what I can do is go into Outpost, and there's a Watchdog tab. I can say add. I'll add a sample Watchdog with the same identifier, OK, and I'll tell it to start pinging by hitting this this box. And what Outpost is going to start doing now is heartbeating this timer, and it does it about every second, and you see the sequence number go up here about every second or two. Yeah, just about every second it heartbeats. One of the features, okay, so now I click back here and you see that the timer is running. I can remove this, and it will take about 10 seconds for this change of the state here to occur, because now basically Outpost is not heartbeating the timer anymore, so the Watchdog will expire. And one of the ways you can update this little thing is by double clicking on it, or you can just kind of move your mouse back and forth, and now you can see that it's expired. Now Watchdogs, the state here goes to and from running to expired depending on if I click this box here on Outpost, so that Outpost can heartbeat. But the Watchdog policy doesn't do anything right now, so I need to add transitions to my Watchdog. So I'm going to add two transitions. One is that when the transition goes from running to expired, I want to activate the policy, and I'll say add. You can also log if that happens. And I'll add another transition that says when it goes from expired back to running, I want to disable the policy. There you go. So once I've got these two state transitions set up, now what I'm going to do is I'm going to start running the Watchdog again, and you can see this went back to running. So so now, of course, when I'm going to go from running to expired, it's going to enable the policy. And what the policy is going to enable is the one that's set right here in the Watchdog engine policy. So I'm going to go ahead and do that. I'm going to remove the heartbeat. Poof. It's removed. And I'm going to wait 10 seconds. And as soon as that heartbeat is going to stop, you're going to see the ping also stop. There you go. It just stopped. Now, and if I go into policies here and say refresh, you'll notice that the ICMP drop policy just turned on and that I can't ping anymore. So I'll start heartbeating again. And as soon as I heartbeat, the network connectivity comes back up. And if I refresh the policies, you notice the policy just was disabled, and so we're back to no policy whatsoever. So that's basically a quick way of understanding how Watchdogs work. You can also log events whenever you go from one transition to another, but of course, don't do that too often because the log is kind of limited in its size. So that's pretty much it. This is a full kind of run around filters, policies, and Watchdogs, and how they work, and how you can demonstrate them to anybody around, and how cool they are. So my name again is Ilyan Saint-Hilaire, and thank you for listening.